Hi, my name is Anna Mirabella, and this is my presentation for the third assignment for CMU's Design, Ethos, and Action course. For this project, I looked at the Mechanical Engineering department and the ways it can be improved. I started the project with a concept map. In pencil are the different points that connect to the Mechanical Engineering department, and in purple are the problems I identified. The different points include the department and faculty advisors, the machine shop, electives, course assignments, the career counselors, and alumni. Problems range from the lack of students' confidence in their machining skills, difficulty finding internships at career fairs, and the steep learning curve that many MECI extracurricular organizations seem to have. However, the points I found most important were those revolving around courses, student learning, and the ability of students to apply what they have learned beyond standard assignments. Here is a simplified model of how I see courses fitting into a bigger picture. For classes, students are given assignments where the hope is that they will learn to apply concepts. Grades are given to these assignments in a way meant to be representative of how students learn, how much learning has occurred. However, the learning itself isn't strongly grounded in this system, hence the dashed box. When it comes to getting jobs, many employers see grades as the primary initial indicator of a student's ability to solve real-world problems. However, the actual learning that has occurred isn't clearly displayed as an indicator, though it is the most important part in being able to solve engineering problems. So the main problem I have identified is that the structured curriculum and pressure to maintain a high GPA do not promote learning for life and creative problem solving. This problem isn't unique to CMU students or my department, but I've been able to see how the structure of our courses is directly related to this. Students can often save time and effort by taking shortcuts to get to the end results expected from them. So the primary stakeholders are the students, faculty, and employers. Students are at the core of this issue since they are essentially the customer at CMU. However, many students don't seem to be comfortable applying concepts, and when we are assigned projects, the pressure to do well on them leaves many people unsure of where to start. No longer having one right answer makes it hard to know what direction to work towards, especially when students are used to the idea that if they put in so much time and effort and follow the given steps, they will be able to earn a certain grade. Students who are investing in this education in the hopes of a long-term payoff. Faculty are held responsible for the performance of students, but they teach in lecture halls where it is nearly impossible to interact with everyone. But the ultimate stakeholder is the employer. They are the ones looking for engineers to solve the problems, but since many companies still hire from behavioral interviews, it can be a gamble as to how well students actually understand the relevant concepts. Ultimately, this matters because the focus has been taken away from problem solving, which is supposed to be the core of engineering. In one of the reading and video pairs we looked at, Barry Schwartz discussed practical wisdom and how people only do things for the incentives. The current system incentivizes students to do well in school by getting good grades. While often learning the material leads to high grades, it is also easy enough to memorize how to solve problems. For example, on an exam where you must know a proof, you could go through the steps to understand the final answer, or you could simply memorize the class notes. Both strategies can produce the same end result on the test, but the understanding that the derivation may take much longer and be harder to work through on your own. Similarly, Dan O'Reilly discussed the presence of dishonesty. People will cheat if they don't feel guilt or consequences. When students see their peers using these shortcuts and earning the same grades, they lose the motivation to put in more effort to actually learn and get the same result as their peers. Ultimately, academic performance can become a dishonest representation of learning. Some students may have practical knowledge that doesn't show on their transcript, while others may have straight A's but still not know the difference between a nail and a screw. Here is one scenario demonstrating the lack of drive to understand the course material. To read the dialogue, I would pause it now, but the issue that arises in this situation is a student feeling that they only need to understand what they think will be on the assessment. There is no demonstration of a desire to learn the material for the sake of learning, and it is viewed as unfair when a new type of problem appears. On the other hand, this situation demonstrates a lack of motivation to explore intellectual interests, if they may require more work or result in lower academic performance. It is common for students to view electives or general education requirements as a means to boost their GPA or at least try not to lower it. As a result, people do not make the most out of these required classes. Here is a storyboard of the current situation. Starting in the top left, we see a teacher speaking to a lecture hall, however, they don't know their students. The teacher assigns a project to the students and declares that it is a competition between them. As a result, there is resistance in the students to help each other, but the pressure to perform well still remains. One student may work for 3 hours and still be struggling to find a solution. However, another student may have finished it after a much longer period of time. There is often nothing stopping the first student from watching his peers and taking in information about their designs. Often classes require submission of initial reports, which are then available to the entire class. It becomes very easy for students to look at the successful parts and attempt to replicate them, and this means that the teacher can't necessarily tell the difference between who put in the initial work and understands the concepts behind them and who's just looking at what others have done. In the end, the original and replicated parts can and often do earn the same grade. Throughout this scenario, the professor has limited visibility as to which students are learning and which students are using these shortcuts. To address these issues, I came up with 3 solutions. The first is to make shifts that encourage students to explore their interests. This could be by allowing students to replace gen ed requirements with a minor outside their major, making general courses pass-fail to encourage students to explore their interests, or make projects open-ended and allow more creativity. The second solution is to foster student-teacher relationships. Currently, most students and teachers do not know each other. If students attend office hours, it is often the course TA, and there can be a stigma against going to office hours because it is seen as admitting you need help. If students were strongly encouraged or required to attend conferences with their teachers, professors could get a better gauge on students, and students may come to have a stronger understanding on why the course material matters. Finally, these problems can be resolved by shifting the emphasis from performance to the process. Projects and case studies allow students to think creatively and solve new problems while applying concepts in abstract ways. However, homework assignments are often graded on correctness, meaning students just work towards an answer. By emphasizing the process, students can be encouraged to take their time to understand the material rather than rush through to get what's listed as the correct solution. The feedback I got on my initial presentation was mostly that I didn't carry through to finding a concrete example of a solution to the problem. The 3 big picture solutions I identified in the previous slide were finding ways to encourage students to explore their interests, fostering student-teacher relationships, and emphasizing process rather than the solution. All of these solutions come together through the implementation of a hands-on project-based student-taught course, or STUCO, for the mechanical engineering department. STUCOs are 3 units, small classes that students can take on a pass-fail grading system. This allows students who are interested in fostering their real-world knowledge to have an outlet to do so that will minimally interfere with their other classes and avoid hurting their GPA. I envision a STUCO where students are given maybe 4 projects for the semester that are all grounded in open-ended topics. For example, one prompt could be design something to do with water. From this, students could choose to explore water purification, create a sensor-controlled water fountain, create emergency flooding kits, or model a thermal fluid system. This would allow students to pinpoint the topics of their interest and explore a solution within that context. A STUCO is also beneficial because of the type of student-teacher relationships it fosters. Since the teachers are CMU students as well, there's less of a barrier to connecting with the instructor. Many students find one of their peers to be more approachable than a professor, and as a result, they may feel more comfortable asking questions and taking risks. Additionally, STUCOs are generally small in course size, which allows the teacher to interact with and keep tabs on the progress of each student. It is much harder for someone to fall behind when they have weekly one-on-one meetings with an instructor. Finally, a STUCO is an ideal situation to emphasize the process. Since the course is pass-fail, there's no increased pressure to make the perfect part or the best in the class. Additionally, the pass-fail course setting allows the curriculum to be structured so that students could even complete 3 out of 4 projects. And given this option to drop one assignment, students who face conflicts with school can choose to focus on their primary courses if they don't have the time for a STUCO at the moment. This means that students can focus on their learning in their actual classes while also investing time and actual care into the projects that they work on for the student-taught course. And they're not just checking off another assignment without actually thinking about the concepts behind it. Thank you for listening to my presentation, and I would love to hear any other feedback through comments on my blog.